the most reliable way to handle any resource from a FastMCP server, whether it's JSON config, plain text, or binary data, uses this exact same pattern. Fetch the content, then check for the attributes you need. We'll see how the client's readResource method returns a collection of content items that you can iterate through, checking each for either text or blob attributes to handle different content types uniformly. This approach works across all resource URI schemes, from local files to remote APIs, and maintains consistency whether you're using single or multi-server clients.
Async with client. Content equals await client read resource. Resource//config/settings JSON. For item in content. If hasheader item text. Print f text content. Item text. Print f MIME type. Item MIME type.
This demonstrates FastMCP's uniform resource interface pattern, where diverse data sources are accessed through a consistent API regardless of their physical format or protocol. The framework abstracts files, configuration data, and dynamic content behind standardized read operations using URI addressing, while preserving type safety through explicit content attributes. The distinctive aspect is how it combines protocol abstraction with strong typing, letting clients handle both text and binary resources through the same interface, while maintaining access to metadata like MIME types. The pattern works by returning resource content as a collection of typed objects, each exposing either text or binary payloads alongside metadata. Clients iterate through the collection and use attribute checking to handle different content types, with the framework managing all protocol-specific details. This design enables the same code to work with static files via file, // URIs, configuration resources via resource, // URIs, or custom protocol endpoints, while automatically adapting to single server or multi-server client configurations. This approach solves the problem of protocol-specific client code by providing a single interface for all resource types. It eliminates the need for custom connectors while maintaining access to raw protocol details when needed. The pattern is particularly valuable in systems that must consume diverse data sources, from configuration files to API endpoints, without coupling to their implementation specifics. The trade-off is a slight abstraction overhead, balanced by significantly reduced client-side complexity and consistent error handling across resource types. Let's break it down line by line.
Async with client.
Async Context Manager pattern for FastMCP client connections ensures automatic resource cleanup when the block exits, preventing connection leaks in async operations. The client's readResource method fetches content from any URI scheme, file, // resource, // etc., returning it as an iterable collection. This uniform handling abstracts protocol details, working consistently across single and multi-server clients. The iteration checks each item for text content using hasheader, a standard pattern that also works for binary resources by checking for blob instead. This dynamic attribute checking handles both single and multiple resource responses.
Content equals await client read resource. Resource//config/settings JSON.
Fetches the JSON configuration from FastMCP's resource store using the standard resource URI scheme. The response returns as a collection, requiring iteration to access individual resource items. The hasheader check for text follows FastMCP's documented pattern for dynamic attribute handling, working consistently for both text and binary resources when checking for blob. This uniform approach abstracts protocol details while maintaining type safety across different resource schemes like resource, // or file, //.
For item in content.
processes each item in the content array returned by read resource. The iteration handles FastMCP's standard response format where resource data is always returned as a collection, even for single items. This pattern works uniformly for both text resources checking, text and binary resources checking, blob, across all supported URI schemes like resource, / or file, //.
If hasheader item, text,
Dynamic attribute safety check. This verifies each item has a text property before access, handling heterogeneous collections where items may represent different resource types. The pattern works uniformly across text and binary resources. Just check for blob instead of text, and supports all URI schemes like resource, // or file, //. FastMCP's consistent attribute model eliminates protocol-specific handling.
print ftext content, item text,
This outputs the text content from each resource item in the collection returned by read resource. The iteration handles cases where resources return multiple items, while hasheader item text safely checks for text-based content before accessing the text attribute. This pattern works uniformly for both text and binary resources, where you would check for blob instead, demonstrating FastMCP's consistent resource handling across different URI schemes like resource, // or file, //.
print fmime type, item mime type,
Outputs the MIME type identifier for each resource item, enabling proper content handling based on format. The iteration handles collections returned by read resource, where each item may represent different content types like text or binary data. This pattern works uniformly across FastMCP's resource URI schemes and client configurations. Resource access pattern. FastMCP2's async resource handling demonstrates uniform access to diverse content types through URI-based addressing, returning collections that require iteration. The same pattern applies to both text and binary resources by checking for text or blob attributes respectively, as shown in the official documentation. Resource URIs support multiple schemes like file, // and resource, //, working consistently across single and multi-server clients.
The URI that names nothing can address everything.